Hey everyone, welcome back to another video by Simplilearn, and in today's session we will learn about C++ STL. But before we begin, make sure to subscribe to our channel and hit the bell icon to never miss an update. So let's go ahead and have a look at what we'll be covering today. In this session we will learn about what is STL, then we will understand the components of STL like containers, iterators, algorithms and function objects. So without further delay, let's get started. STL stands for Standard Template Library. It is a set of template classes that provide us data structures and algorithms or containers. It allows the programmer to use predefined functions which helps them to write the code quickly and in an efficient way. For example, you are solving a problem that needs sorting. Now instead of writing the code to sort, you can make use of STL. Now STL mainly consists of 4 components, that is containers, iterators, algorithms and function objects. So first is containers. These are collection of objects that store data of similar type. In STL we have different types of containers. Some of them are array, vector, set, map, and these containers are generic in nature. So further, these containers are of 3 types, that is sequence container, associative container and container adapters. Sequence containers, these are those containers that can be accessed sequentially. For example, vector, deque, list are some of the containers that store data in a linear form. Next is associative container. These are those containers that implement sorted data structures. In this, elements are retrieved via keys and each associative container maintain its keys in sorted order. Example, set, multiset, map and multimap. After that, container adapters. These containers are like sequential containers, but they are implemented by modifying their interface to provide the desired behavior. For example, stack queue and priority queue are some examples of container adapters. Now coming to iterators. In STL, iterator plays an important role as it links algorithms and containers. Iterators are those entities that helps in traversing through containers. They are used to point at the memory address of the STL containers. Iterators also helps in traversal from one element to the next element in the range using operators like increment operator. Iterator contains 2 functions, that is begin function and end function. The begin function returns the iterator to the first element and the end function returns the iterator to the last element. Now coming to algorithms. Algorithms in STL can be defined as procedures that are applied to the containers and provide some operations on the content of the container. And because STL algorithms are built in, so that is why they save considerable amount of time. In algorithms, we just have to make a function call and we don't have to write the lines of code to implement it. Now let's have a look at types of algorithms. First is modifying algorithm, non-modifying algorithm, sorting algorithm, searching algorithm, and numeric algorithm. Modifying algorithms are those algorithms that make changes to the sequences. Swap and reverse functions are some examples of it. Then non-modifying algorithm. Non-modifying algorithm are basically read-only functions. They do not modify the data on which they work on. Some examples are count, equal, and search functions. Then sorting algorithms. This algorithm is used to sort the container elements. Its example is sort function. Next is searching algorithm. As the name suggests, this algorithm searches for the element. Binary search algorithm is mostly used search algorithm. Last is numeric algorithm. This algorithm works on numeric values, or we can say it solves some numeric problems. Examples are accumulate function and partial sum functions. Now coming to function objects. Function objects are also known as functors. A function object is an object of template class that implements call operator. This call operator allows the object to be used with same syntax as regular function call. For example, suppose you have declared an object obj of a class in which operator is defined. Then you can use the object obj just like a normal function. Function objects also helps in generating the data, and it also helps in testing purposes. Now, in order to do some examples, let's move to our code editor, that is VS Code. So here we will do an example of vector container. So let's make a new file. And let's name it stl.cpp. Now we'll add the header files. Now writing namespace standard. Now we will add, before namespace standard, we have to add the header file for vectors, because we are doing the example of vector, so that is why we have to add the header file of vector. Okay, now we'll write int main. Now first of all we'll declare the vector. So we'll write vector int within the angle brackets. Now we will write the name of the vector, that is v. Okay, now we have to push some elements inside the vector. For that we have to use for loop. So we'll write for keyword int I equals, let's say 1, I less than equals 10, I plus plus, that is increment operator. Okay, now we have to push the elements one by one, so we'll write v dot push back, and inside the bracket we'll put I. So the elements will keep on adding one by one at the end of the vector. So now we will check the size of the vector. So we'll write the message size and then the function v dot size. It will tell us the size of the vector, that is the number of elements inside it. As we can see that we have put 10 elements inside the vector one by one, so it must be 10. So in order to check it, we have used this function v dot size. Okay, now we'll use another function, that is v dot resize. It will resize the size of the vector. So whatever we put inside this bracket, like let's say I've put 7, so its size now would be 7. And we need to check this also. So we'll again use the function size. So first of all we'll display the message. After resizing, it becomes v dot size. It will print the size of the vector after resizing. Okay, now we use another function v dot empty. For that we have to use if condition. So we'll write v dot empty brackets. We know that if v dot empty equals true, then it means it is empty, and if it equals false, then it means it is not empty. So we'll simply display the message that it is not empty. We'll write cout, and now we'll write with /n not empty. We forgot to write the commas over here. Okay, now in else we will write it is empty. It is empty. We can also do this the other way around, like we can put v.empty equals to true, and then inside that bracket we can write it is empty, but it's your choice. Okay, now we'll display the elements of the vector. For that we have to first write the message. So we'll write elements of vector. Then after this, using for loop and iterator, we will print those elements. So let's do this. We'll write for, and inside for loop we'll write auto it. Here the auto keyword specifies the type of variable that is being declared will be automatically deducted from the initializer, and it is the iterator. Now we'll write it equals v.begin, and we know that v.begin function will point to the first element of the vector. So after that we'll write it not equal to v.end, and it will point to the last element of the vector. Now we'll write it plus plus. Now we'll print the iterator using dereference operator, and in order to make some space we'll write this. Now return 0. Okay, now let's try to run this. Okay, here is the problem, I think. Now let's try one another time. Here it is, size 10. After that, after resizing, it becomes 7. Firstly, we add the elements by pushing one by one using the pushback function. 10 elements were added, so size is 10. After that we have resized it, so after resizing it becomes 7, and then we have used the function empty, so it was not empty, so that is why the message displays not empty. Then the elements of vector, I forgot to put space over here, and elements of vector 1 2 3 4 5 6 7, and that is correct. Okay, now we'll do one example of iterator. In this example we'll simply print the elements of a vector using iterator. So first of all, let's name this STL2.cpp. Now we'll write the header files, hash include iostream. In this we'll add 3 header files. Now we'll write hash include iterator, because we have to use iterator, so that is why we are doing this. And we also have to use the vectors, so we'll write hash include vector. Now we'll write namespace standard. Now we'll start with int main. So first of all we'll declare a vector in which there are some elements. As in previous question we already learned how to add elements in a vector, so in this question we'll simply declare those elements inside a vector. So we'll write vector int inside the angle brackets. Now let's say AR is the name of this vector. Now we'll write the elements. Five elements are there. Now we have to declare iterator to a vector. So this is how we'll do it. We'll write vector, then the data type inside the angle brackets. Then after this we'll write the scope resolution operator like this. Now iterator keyword, then the name of the iterator, that is PTR. Now we'll display the vector elements using for loop and using the functions begin and end. So we'll write, first of all we have to display a message. Okay, we'll write the elements of vector R. Okay, now semicolon. Now using for loop we'll write the PTR, that is the iterator, AR dot begin. As we know that AR is the name of the vector. AR dot begin. Begin function will point to the first element of the vector. Then PTR less than AR dot end. We know end function will point to the last element of the vector. Okay, now we'll write AR plus plus. Sorry, PTR plus plus. Now we have to display it, and we'll display it using dereference operator and the name of iterator, that is PTR. We'll make some space. Now at last we'll write return 0. Now let's try to run this. The elements of vector are, as you can see, the elements of vector are 1, 2, 3, 4, 5. So this is how you can print the elements of a vector using the iterator. Here is the vector, and with the help of iterator we have printed these elements 1, 2, 3, 4, 5. Now we'll do one simple example of algorithm. First of all, let's name this STL3.cpp. Now in this example we'll use swap algorithm to swap two integers, and we know that swap is a template function. So let's do this. First of all we'll write hash include iostream. Now using namespace standard, we'll start with int main. Now first of all we declare a variable, let's say 7, and second variable, let's say 10. First of all we'll display the value of these variables, that before swapping and after swapping. So that is where we'll write value of I. Now here we'll write value of j. And L. Okay, now we'll use the swap algorithm, and here we'll mention the elements we want to swap, I, j. will simply swap the contents of these two elements. Now we'll write after swapping. And then we'll do same for J. This is a very basic example, but we have to see the functionality of it. We'll write and okay. Now we'll write return 0. Now we'll run this. Yeah, value of I 7, value of j is 10 after swapping I 10 j 7. It will look better if we have wrote like this. Let's make it look good. Yeah, value of I is 7, value of j is 10. After swapping, I becomes 10 and j becomes 7. So this is how we can swap the elements using swap algorithm. There are some more algorithms, you can try those as well. And now at last we'll do one example of function object. Let's name this as STL4.cpp. Alright, now we'll add the header file. Hash include iostream. Now we'll write namespace standard. Now in this question, first of all, we'll start with the function. So first of all, we'll make a class function obj. Now we'll write access specifier public int. Here we'll write the call operator. As we know the syntax, operator bracket, then another bracket for the arguments, int x comma int y. So this is the syntax of it. And now whatever we want to do with these two variables, let's say we want to multiply, so we'll write return x into y. Alright, as this is a class, so we have to write the semicolon. Now we'll write int main. Okay, now we'll write int main. After int main, here we will write the name of the class, because we have to define the object of it. Now the object is fo. So here class name is function obj and its object is fo, and as I have explained earlier, here I can use fo object like a normal function, because fo is the object of class function obj in which call operator is defined, so it will act like a normal function. So now we'll make a variable, let's say multiply, so we'll write mult equals fo, and because it acts like a normal function, so we'll pass the parameters 4 and 7. Now in order to display, we'll write cout and we'll write multiplication of x and y is, now we'll write the name of the variable mult, because the result is getting stored in mult variable. Now we'll write return 0. Now let's try to run this. Here we can see multiplication of x and y is 28, and that is true. 4 into 7 equals 28. So it is working, and this is the example of functor or function object. So these were some basic examples of components of STL. You can practice some more examples on them in order to learn. Alright guys, with that we have come to the end of this video. If you like this video, please give it a thumbs up. I hope it really helped you all. Thanks for watching, stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.